Hello, today we're going to be talking about couples. So a couple is going to be a set of equal and opposite but not collinear forces. So as an example of a couple we've got this here. So here I've got one force going up, another force with an equal magnitude, opposite direction pointing down, and you'll notice they don't line up. So with this set of force, we've got no net force because we've got two equal and opposite forces, but this whole thing is going to exert a moment. So if we let it be as is, the whole thing would start to rotate, but there'd be no linear acceleration to this. So with this setup, since we've got no net force, but we do have a moment, these couples are sometimes also called pure moments. And so the couples can be represented either as a set of forces. So down here we could have a person kind of torquing a lug wrench here. It's going to be one force down, one force up to turn this thing, so it can be represented as those two forces. Or sometimes we just represent it as the moment that this set of forces exerts. So with this, we've got, in addition to kind of this pure moment where there's no net force, there's also another interesting characteristic to couples. So with a couple, they're going to exert the same moment about every point. So we can do a little test here where we check this out. We're going to take the moment about point A from these two forces. So this force over here, 60 pounds, 1 foot. The moment is F times D. So 60 foot-pounds in the negative Z direction. Over this force over here, we've got 60 pounds times 1 foot. 60 foot-pounds, again in the negative Z direction. So negative 60 foot-pounds plus negative 60 foot-pounds. We've got a moment about point A of negative 120 foot-pounds. So let's do this again with point B. So at point B, we've got 60 pounds times 2 feet, F times D. It's going to be in the positive direction. So I got positive 120 foot-pounds. I need to add in the second force, so 60 pounds, and I'm going to have 4 feet from the end to point B over here. So 60 pounds times 4 feet, it's going to be 240, and that is actually going to be in the negative Z direction. So negative 240 foot-pounds plus positive 120 foot-pounds gives me a total of negative 120 foot-pounds. And we can try it with some other points. We're always going to find the same result. This couple is going to exert a moment of negative 120 foot-pounds about any point on our beam. So with this, the moment that our couple exerts is always going to be the same. It's going to be F times D. And in this equation, M is the moment exerted by the couple about any point, because once we find it about one point, it's going to be the same anywhere. F is going to be the magnitude of one of our force vectors. So in the previous example, that was 60 pounds. And D is going to be, rather than the distance from the point to the force, it's going to be the distance between these two forces. So we've got this force over here, and we have a total distance of 2 feet in our previous example. So the moment exerted by this couple is going to be 60 pounds times 2 feet, or 120 foot-pounds. And again, we're going to use the right-hand rule to kind of figure out. So this whole thing would rotate this way, and that's going to be in the negative Z direction, so negative 120 foot-pounds about any point on our body. And so with that, that's all we need to talk about with couples. Thank you for watching, and I hope to see you again.